Hello, everyone. Thank you for joining this session. My name is Vijay Arungurikai. I work as a solutions architect at Red Hat in region North America. I work for the ISV partner team. I also have Vince Power, who's the principal solution architect at Red Hat, working for the global ISV partner team. Today, my focus would be on the presentation. Vince would lead the charge with the demo. With that being said, let's get started. Today, we will be talking about Red Hat's OpenShift container platform and Couchbase NoSQL database. And based on that, we want to also focus on why do you need to take a multi-cluster and a multi-cloud approach? What are the challenges typically faced by different personas in an IT organization interacting with a multi-cluster environment? At a higher level, we want to provide you with an open overview of OpenShift container platform. More specifically, some information we want to share with respect to operators. How does OpenShift Container Platform help with consistency and portability? What is Red Hat's advanced cluster management product and what some of those capabilities are? Vince will then demo the following features. He's going to show you how to manage multiple OpenShift clusters from a single console. He's also going to deploy Couchbase across these multiple clusters. And we also want to highlight some of the key decisions need to be made in designing your hybrid multi-cloud environment. So what is multi-cluster and why do you actually need it? A multi-cluster approach is setting up independent, isolated clusters that in an organization. They are set up for a variety of reasons, including resiliency. That is, they could be in different data centers in an on-prem environment or different availability zones, or regions in a public cloud environment such as AWS, Azure, or the Google Cloud. Security policies could be different. That is, each cluster in the multi-cluster environment could be tagged as development or test or production environments. Policies defined and implemented will vary across them. Who gets to access to what? Data segmentation, that is, data residing in a production environment is of course more sensitive than data in another lower level environments. What is multi-cloud and why you need it? Multi-cloud approach is deploying clusters in different on-prem data centers or across the available public clouds. You would need both of these because it might be due to your end customers' requirements. You would want to address scenarios with respect to disaster recovery, setting up clusters across multiple clouds to mitigate the risk of catastrophic failure, setting up clusters closer to where the data is in the case of edge computing. In an IT organization, there are always different personas who use, maintain, and manage the IT infrastructure and the data. The requirements greatly vary across these different personas as well. From a developer's perspective, they want to build, deploy, and test a container application and move on to the next task assigned to them. They want self-service capabilities to install and test these applications. They want to move successfully tested applications from development all the way to production as quickly as possible in an automated fashion and maintain configuration across all environments so that the application built once truly runs everywhere as envisioned. For DevOps personnel, consistency is key to provisioning clusters. They want to create, maintain, and enforce policies across these clusters wherever they are. They also want to easily find and modify resources across these clusters. In a hybrid multi-cloud approach, clusters can be anywhere and everywhere, that is in the public or private clouds, in different geographies, and also on the edge. You need to have the capability to view them from a single pane, be able to deploy applications and services across these clusters also. You need to know what is running where and when auditing and keeping the applications and the clusters themselves in compliance. So at a higher level, from an overview perspective, OpenShift 4 or 4.5 to be more specific, which is the latest version that's available, is a smarter Kubernetes platform because we have streamlined both the installation and the upgrade experience. You can be up and running with a fully configured Kubernetes cluster in less than 15 minutes, including metering and monitoring at the cluster level, application and with developer services. Kubernetes updates, security patches, and component updates can be deployed with a single click. Based on RHEL CoreOS, OpenShift can actually update the underlying operating system and scale at the node level, which is particularly useful when you deploy OpenShift on cloud infrastructure because the entire cluster can scale up and down based on your application needs. Scaling scales with your needs from 10 containers to 10,000s of containers is possible. Operators automate a lot of day one and day two operations, such as provisioning, backup, scaling, etc., which will help the DBAs and developers to focus on more project-centric and strategic tasks. Operators make databases more accessible and supported as well. A variety of database and data analytics workloads have made custom operators available on Red Hat's OpenShift container platform. Red Hat also actively works with the database and data service ISVs, including Couchbase, to ensure that the operators are certified on OpenShift and they are secure and have regular scans so that you can use it from the get-go. OpenShift Container Platform gives you a secure deployment. It gives you operations and portability in a consistent way across the hybrid cloud. Red Hat's OpenShift Container Platform offers a unified, consistent manner of deploying databases and data analytics and all workloads on the same platform across different phases of your app dev lifecycle, whether be it in development, test, or in production environments. These deployments and operations are secure and can be done in a consistent manner across the hybrid cloud. Red Hat's OpenShift offers several options, such as fully managed, that is OpenShift dedicated, or OpenShift on Azure, that's called ARO, or OpenShift on AWS, that's called AMRO, and OpenShift on the IBM Cloud, and self-managed options to accelerate deployments by choosing either the OpenShift public cloud hosted or self-managed options. So you get a seamless OpenShift experience, whether you deploy it on-prem or across the public clouds. Red Hat's advanced cluster management for Kubernetes provides end-to-end visibility and control for all your Kubernetes clusters. It controls the clusters and applications from a single console with built-in security policies. RACM, or Red Hat's Advanced Cluster Management, extends the value of OpenShift by deploying applications, managing multiple clusters, and enforcing policies across multiple clusters at scale. With that being said, I would like to hand it over back to Vince, who will be demonstrating the capabilities of OpenShift and Couchbase and RHACM to you today. Thank you.
Okay, thank you. Now let's go through a live demo just to show using Advanced Cluster Manager with OpenShift and how to install Couchbase and set it up for replication. It's really, only 15 minutes work or so to get it done, to get the basics, and then of course you can expand beyond that if you want. So this is Advanced Cluster Manager. The basic functionality. You can observe environments, automate installs, manage applications. For this demonstration, because it's operator based and self-managed at the cluster level, we don't need to manage any applications from ACM. That is a possibility. So right now we've got two OpenShift clusters deployed. They're both on Azure, and they're running OpenShift. So the first one, we'll just click on it. So this gives you the basic instructions for what you have for your cluster. Your console URL, any violations, any active nodes you have. It'll actually list all the nodes for you, give you details on them, like the instance types, memory and core being used. What's nice about cluster management ACM is you can add new clusters right from this console. So you can import one that exists that works for almost any Kubernetes distribution, but you can create OpenShift clusters on the largest hypervisors. It deploys the infrastructure along with OpenShift on top of it. It's all managed from this console, which makes it nice and easy to manage your holistic environments. Does my what cloud you're on. So this makes it really easy to spin up disaster recovery sites, secondary sites, test environments, or even manage your production environment to grow it all automatically. So let's go to the first OpenShift cluster that we're logged in. So this gives you an overview of the cluster once you're in it. This is the regular administration console. This one already has Couchbase installed, so I'm just going to kind of walk through what's involved with setting that up, and then we're going to actually do it on the second cluster. So the first thing to note is to go to installed operators and see there is an installed operator in place. When you go to the operator, it gives you all kinds of API options available, everything from backup management automatically, RBAC for groups, roles, users. Like we have a group and a user predefined and a binding set up so it's enabled or configured. That way we can actually query the system. There's one default bucket set up. It doesn't really have anything in it, but you need a bucket to do anything. And then we have a cluster running on this instance. So in this cluster, it's got 3 members. It's just pretty much straight out of the box. We'll go down. We aren't using TLS in this instance, but this just kind of gives you the basic idea. The other option, you'll notice an option here called XDCR managed. If you enable that, replication is actually handled from part of the configuration within the operator instead of actually in the Couchbase console. We're going to use the console for this demonstration just to show you how it works and how easy it is to set up, but you can actually do it as part of the actual YAML configuration. Where you expose features, and then later on you can actually expose more advanced functionality, like actually add your remote servers and everything that you need. But we're not going to do that for this purposes. So as you can see, it's all working, it's running. If we go to the project it's in the default project. We can see there's the deployment it has running, and it's got 4 pods. It made services automatically for all the different pieces it needs, and we created one route. This route exposes the web service port, which allows us to load up the actual Couchbase console, which will show the servers, show they're all healthy, and all that stuff. We don't have anything defined in replication right now, just to show it's working. So now we're going to go back to ACM, and we're going to go to the second cluster. And now we're in the second cluster. So this cluster doesn't have any operators here. I'm on all projects, and there's no other operators installed. So we're going to install the Couchbase operator. Okay, there are 2 Couchbase operators. There's a marketplace offering, which is where you can have a self-serve capability tied with Red Hat Marketplace to buy a license. And there's the regular operator, which is if you're doing a trial, or if you're just or you have an existing license. So for our purposes, we're going to use the existing, the standard operator. As part of every operator, there's capability levels, so basic install, seamless upgrades. So Couchbase is a fully realized level 5 operator that can do its own deep insights, its own autopilot. It's worked. It's certified by Red Hat, so we know it's worked, and that way we can jointly support it. And there's lots of documentation where to go. So we're going to install the operator. So it's as simple as clicking install. For our purposes, we're just going to use a single namespace, because that's all we need for what we're working on, and this just shows the provided APIs that are available. So now we're going to install it. As it refreshes, comes back up, we can see we're in the default project now, and it has now successfully been installed. So if we go to the projects pod, we can see there's a running Couchbase operator inside the project we selected. So for Couchbase operators, now the first thing to do is we need to create a cluster. But before we can create a cluster, there's a requirement that you need a secret set up for you need a secret setup, which allows for the creation of username and password for the console. There's also a couple default bindings for user and group, which are so in the secret. There's a user, just a default user we're going to use. This is the mapping for the user. This is the group that gets defined, and then here's the role binding. But this top one here is the secret that gets used as part of the cluster creation. The rest are just kind of used for other features that need to be there, but it's just kind of a long process to actually map them manually. So we're just going to do OC apply to create the items. Actually, make sure they're not there first. So, yeah, all right. So this is going to create them. New versions. If you want to use kubectl, you can. Most of the functionality is there, but OC is Red Hat's specific command that allows for all the additional functionality inside Red Hat to be there, like listing all the projects that are available. The different functionality like that. But at this point, we've got our secret made, so we'll go back to here and we can verify it. Project default, and there's our example admin. So now we're going to go into our operator that's running, go to a Couchbase cluster, create the cluster. This can be done through either YAML or if you're doing a very simple install like we're doing, you can just do it through the drop-down lists. So we need to create our admin secret just to make sure it's selected so we can log in, and everything else we're just kind of leave alone. And as I mentioned before, there's this XDCR here that if you manage it, it allows you to define the clusters and everything ahead of time, but I want to show that creation process just so you can see it working. So we're going to leave it unmanaged. So now we're going to create the Couchbase cluster. So it's starting up the process. If we go to the cons, we can. Oh, we're faster than it is. So we'll start to see services are being rendered, created, and pods are starting to be created. That'll actually map. That'll actually the Couchbase server being spun up automatically, and it'll do three nodes by default. So there's the second one being spun up. It's creating, running, and then as part of this, we need to create a bucket, which is just how Couchbase kind of it stores its data. So we're just default's fine. We don't need to change any of these values. We can just create it, and as soon as it's ready, so the Couchbase cluster says it's running, and so as soon as the bucket's created, it'll tell us. But we need to be able to access the web console. So we're going to go and add a route. There's already one here, but we'll just create one really quick. So to create one, it's just as simple as create route. We're doing the UI, but it's actually the full web service API is available through this URL. Not just the UI is the simple one, and then from which service it's available. Since we're using the UI mainly, we're going to select the UI, and target port is 8091, which is the default web service port. You leave hostname blank, just then it's automatically generated. If you want a custom URL, you can select it yourself. So that's made a route now that's available. So let's check to see if all our pods are running. They're running and they're all ready, just perfect. So now if we go to our routes and open it up, okay, and that opens up the console, so we can log in, and it shows a fully functional cluster running with the servers are all available, they're all balanced. It shows our bucket, how much memory disk it's using. As you can see, for replication. There is nothing set up right now. We'll get to that next to show how easy it is to set up replication, and they were new buckets, so there's nothing in them. So this will be the first cluster. As part of how we're setting this up, just to show how some of the features that's available doing multi-cluster. We're actually using this on Azure between regions. So we have in our virtual network, we actually have peering set up. That way we don't need to worry about encryption as much, and it's not going over the public internet. Right, so we've got encryption between the two zones to allow traffic back and forth. So now we're going to do, and now we're going to make a replication agreement. So we're going to grab an external address here, and we're going to open up the open this up for the other cluster. It's actually case sensitive for what's in the secret, if in case you ever do this and it doesn't log in for you. So we're going to add a remote. We're connecting to the first cluster. We have the host IP. There is a space that you need to clear out with the copy pasting, and if this saves, then the replication agreement's good. And it saved. That's awesome. So now we're going to set up. So now we got a remote server connected, and this is all push based. So we're going to add a replication agreement. So we're going to go replicate from default to the remote cluster, and we're going to use the default remote one. It actually gives the list, so you know it's pulling data back and forth. And now it says it's alive and it's replicating, which is awesome. So now we're going to go just put in a sample document. We'll just call it test. Just to show it's custom. For this, it's saved, it's in. So there's the document there. Now when we go back to the other cluster, if we go to the bucket documents, it shows that it actually did replicate it. Now if we want two-way replication, we just could do the same thing in reverse, and everything is functional great. But this just shows it's up and running. It's running over a private network between two data centers, and all the actual clusters are managed by Advanced Cluster Manager, which allows us to add more, and then we just go in and add an operator, do a little bit of config, and point it at the next cluster, and you can get in multi-cluster, multi-data center, or multi-regional replication up and running with almost no work, all from the command line, all from the web interface you want, or all this is available from the command line using a set of tools. And yeah, this is why Red Hat and Couchbase is a very good, solid partnership where we provide the infrastructure, abstract it from the cloud, and Couchbase provides the NoSQL capabilities that modern applications need to drive performance. Okay. Thank you for your time, and if you have any questions, just feel free to reach out. Thank you.